Hello everyone and I welcome you all to today's video. Today we are going to take a look at k-means clustering algorithm and we are also going to see an example of k-nearest neighbor algorithm. We are going to understand this concepts by solving a question of end semester question paper. My name is Manas Pathak and I am a student of IIPS DAV. So let's start. In the previous video, we saw the difference between the supervised and unsupervised learning algorithm, parametric and non-parametric models, and also saw several evaluation metrics for classification, the link for which you can find in the description of this video. The question for today is, explain k-means clustering algorithm with steps. Discuss how initial centroids influence results. Part B, completely demonstrate the clustering algorithm and compute KNN classification using Euclidean distance. So let's solve all these parts of the question one by one. Let's start by understanding what is the k-means clustering algorithm. K-means clustering groups similar data points into K clusters without needing labeled data. It is used to uncover hidden patterns when the goal is to organize data based on similarity. So in k-means clustering, we group the data into K clusters. Here K is a predefined integer number. So before we start the algorithm, we decide that our data set should have K distinct clusters or distinct partitions. Since this algorithm doesn't need a labeled data, it is an unsupervised learning algorithm, and the main goal in k-means clustering algorithm is to find the hidden pattern. So it is not used for prediction or classification. It is used to identify the different patterns which exist in our data and are not clearly visible when data is just presented to us in its raw form. So let's understand further features of the k-means clustering. It helps in identify natural groupings in unlabeled data, works by grouping points based on distance to cluster center. Now by distance, for calculating distance or similarity between a data point and a cluster centroid, we use the distance matrix which can be which is generally the Euclidean distance. We can also use some other distance metric like Minkowski distance or Manhattan distance, etc. Commonly used in customer segmentation, image compression, and pattern discovery. So these are the applications of k-means clustering. If I tell you about the customer segmentation, k-means clustering is used to segment the customers by their purchase behavior, so that the company or the organization could could study about the different purchase behaviors of different customer and make decisions accordingly about their new products or pricings. One of the application of k-means clustering is also an outlier detection. It helps in identifying the outlier values in our data. Useful when you need structured from raw unorganized data. So I already told you that it is difficult to identify the patterns from the raw or unorganized data. So using k-means clustering can aid us in creating different patterns. Now let's understand the working of k-means clustering. The dataset in k-means clustering consists of items having certain features having values like vector. So the data points in k-means clustering are often considered as a vector. The goal is to partition the dataset into k clusters such that data points within each cluster are more similar to each other than to those in other clusters. To calculate the similarity, we will use the Euclidean distance as a measurement. The algorithm works as follows. Initialization. We begin a step, which is this first step. We begin by randomly selecting k data points as a cluster centroid. So this is the most important step in k-means clustering. We will further discuss about its importance in further slides. In this step, we randomly select k data points and we assign those data points as a centroid for the k clusters. So so if we have decided there will be three clusters in k for my data, then I'll select three random data points and those three data points would be my three centroids for three clusters. Second step, assignment. Each data point is assigned to the nearest centroid forming clusters. So now once we have decided the selected certain centroids, certain data points at centroid, we will find for each rest of other all data points will find the closest centroid to them. Now we'll find this closest centroid by using the distance metric. So the distance metric which could be Euclidean distance or some other distance metric comes into play in this step. The third step is update step. After the assignment, we recalculate the centroid for each cluster by averaging the points within it. So once each cluster has been has certain data points under it based on the similarity with the centroid with its centroid, we will average all the value all the corresponding values for of all data points for that cluster, and what would the result of that average would be a new data point which would serve as a new centroid for the cluster. The next step is repeat. This process repeats until the centroids no longer change or the maximum number of iterations are reached. So the k-means clustering ends in two conditions. One where we have reached the point of convergence. By convergence I mean in two successive iterations there is no change in assignment of centroids for data points, and or we have reached a certain maximum amount of iteration which we had already decided before beginning of the algorithm. So I hope you understand that. Demonstrating k-means clustering using an example. So now here we are going to take an example to demonstrate you how k-means clustering works. So now I have taken here 4 data points in a 2D space. My data points are A 1, 1, B 2, 1, C 4, 3 and D 5, 4. Now the first step is initialization. Hence I'll here use the value. I'll take the value of K as 2. So I'll select two initial centroids, two data points as to serve as centroids for my two clusters. So we select two initial centroids. We pick points A and C randomly as our starting centroids. So here my two centroid data points picked as centroids for two clusters are 1, 1 and 4, 3. I'll name 1, 1 as M1 and I'll name 4, 3 as M2, which is my first and which are my first and second centroids respectively. Now for the assignment step, I already told you that we use distance metric here to measure the distance of each of the data point with different centroids and find the closest centroid. For that we use a distance metric. Since we have to use the Euclidean distance here, we are going to use this formula of Euclidean distance, which is square root of sum of square differences between corresponding values of two data points. So this is the calculation of Euclidean distance here. So for all data points, we have calculated their Euclidean distance with the first centroid and the second centroid. And then we have found the nearest centroid based on the closest based on the distance which is the smallest. So here in the first case the distance of point 1, 1 to the centroid 1, 1 is obviously 0, while its distance to another centroid 4, 3 is 3.61. Hence the nearest centroid would be 1. Similarly, in this case, in the second case, for point 2, 1, the nearest centroid is M1, which is 1, 1, because the Euclidean distance from of 2, 1 from 1, 1 is 1, while its distance with the another centroid is 2.83. Hence, the nearest centroid would be M1. Hence, we'll find the nearest centroid for all the data points and assign the cluster of that centroid to the cluster of that centroid to that data point. Now the step 3 is the updation, where we will update our centroid. So now for the first cluster, the first cluster consists of two data points which are 1, 1 and 2, 1. We'll take the average of their corresponding values, and hence after calculating the average we get the new centroid for first cluster as 1.5, 1. Similarly for the second cluster, I'll calculate the new centroid for the 2 points under it, which are 4, 3 and 5, 4, the average of which comes out to be 4.5, 3.5, which is the centroid for my second cluster. Now again calculate. Now we'll again repeat the process of assignment. Hence we are going to again the calculate the distance of each data point with the given with the new clusters, updated cluster centroids, and based on the distances we will choose the smallest one as the nearest centroid and assign that data point to the cluster to which that centroid belongs. So I hope you get that. Now, the grouping of points did not change from iteration 1 to iteration 2. Hence, cluster 1 still consists of 2 points which are A and B, and cluster 2 still consists of points C, D. Since the clusters are stable and the algorithm stops here. So here the algorithm stops due to we have reached the point of convergence and not the maximum number of iterations. Here there was no change from first iteration to second iteration in the assignments of the clusters to data point. Hence we have reached the convergence and the algorithm finally stops. So our final result would be the algorithm has successfully separated the data into two distinct groups based on their locations. Group 1 lower left points A, B. Group 2 upper right points C, D. Now we will understand how the first step of initialization, the initial centroids, influence the result of our overall algorithm. The choice of initial centroids is one of the most critical factors in k-means clustering because the algorithm is sensitive to initialization. Since k-means uses a greedy approach, it moves towards the nearest solution rather than exploring all possibilities. Where you start determines where you end up. A poor starting position can ruin your results. So the k-means clustering, as it has already been written here, that it is a greedy algorithm or as a greedy approach. So for this algorithm, the most important thing is to quickly converge to a nearest solution, then to find the best solution for the given data. So the best solution by me here refers to the global optimum, and the nearest solution is also called the local optimum. So the k-means algorithm, based on its initial assignment, converges to the local optima, which is the best result it could get depending upon the near initial centroid assignments. So this is one of the disadvantages or and challenges with the k-means clustering, that you might not get the global optimum or the best result with the algorithm because it highly depends on the assignment of initial centroids, which makes the first step of initialization very important for our algorithm. Let's understand the three main problems which are associated with the initial assignment of centroids and how they influence the result. The local optima problem. As I have already told you about it, k-means clustering doesn't guarantee finding the best possible clustering, the global optimum. It only guarantees finding a local optimum. So if we have done a good initialization, the algorithm will quickly converge to the true center, whereas a bad initialization, by bad initialization I mean that initialization done that the cluster centroids are initialized to centroids for clusters are initialized in the outlier regions, or certain two centroids are initialized very close to each other. So two cluster centroids are very close to each other. So this is an example of a bad initialization. So this cases would lead to a local optima only, and we can't achieve the result which is 100% reliable and gives a proper understanding of our data. How initial centroids influence results. Again, we are going to look at here about the impact of initial centroids on the result. So the second impact would be the impact on convergence speed. The position of initial centroid dictates how many iterations the algorithm needs to run. Far from solution, if centroids start from high density areas, they must travel across the data space over many iterations to find the center. Near solution, if initialized intelligently, the centroids might only need minor adjustment, causing the algorithm to converge in very few steps. So the better our initialization is, the faster the algorithm converges, and the more bad our initialization is, the more time it takes to converge. Empty clusters. In rare cases with a random initialization, a centroid might be placed so far away from a data or in such a way that another centroid is always closer to every other data point that it ends up with 0 points assigned to it. This might cause the algorithm to crash. KNN. Now let's implement the KNN to the given data set. In this data, I have 10 data points. Each For each I'm given the height 8, age, and the weight, which is my target variable. Now I am supposed to find the weight for the 11th data point, which has height 5.5 and age 38. So we will start the implementation of KNN by calculating the Euclidean distance of each of the 10 data points with the 11th data point. So let's calculate the Euclidean distance for all the points first. The Euclidean distance is calculated as under root of h minus 5.5 whole square plus a minus 38 whole square, where h refers to the height and a refers to the age of different data points. So in the last column, I have the Euclidean distance for all the given 10 data points. Now, depending upon the value of k, I'll start from the smallest distance and I'll collect the data points until I have collected the k data points in from my data. Now we are using the value of k here 3. So the 3 closest neighbors to the given point are id equals to 6, id equals to 5 and id equals to 4. The corresponding weight for which are 60, 72 and 59. So we'll find the average of these three weights, which comes around 63.67. Hence therefore we predict the weight 63.67 for the given data point. So for the 11th data point, which has height 5.5 and age 38, the value predicted by us for weight is 63.67. So this was all about today's video. I hope you learned something from here. I would like to give my sincere gratitude to Dr. Shaligram Prajapat for guiding me throughout the semester. If you like this video, consider subscribing to my channel and liking this video. I'll see you in next video. Thank you.